how to run Kubernetes on vSphere for free, the open source way. My name is Kenny Coleman. I am a senior technical product line manager, marketing manager, whatever you want to call me at VMware, focused on some open source tooling as well as Tanzu Kubernetes Grid, which we'll talk about here in a little bit. Now, I'm going to do a little bit different here. I'm actually going to dive really into a demo and kind of get this started so you kind of see exactly what's going on here. I filled out a bunch of information that I've built into a script. I'm going to go ahead and press enter, and then we're just going to go ahead and leave this, and we'll come back to it in a little bit. All right, so as that's running, let's go ahead and talk about Kubernetes. Because we need to understand why we're here today is actually talking about containers first off, because containers are doing to operating systems what virtual machines originally did to server hardware by making some sort of ubiquitous abstracted layer. Virtual machines made us not really care about the underlying hardware, but instead we focused on our virtual machines and our applications. Now, containers themselves are even taking this a step further because we're democratizing the operating system now by being able to put a container, put the application as well as the dependencies inside of there. It makes it not only into a small footprint, it makes it super lightweight, super portable, and highly scalable at the same exact time. Now, we can all remember when we did our first P2V and what it was like to try and get everybody on board with virtualization. Now, virtualization is everywhere. It's mainstream. We all know it. And now that containers are coming along, it's taken a much rapid approach of actually doing this adoption cycle because we were so used to actually utilizing virtual machines that containers are just the next instantiation of being able to package your application. So it's doing this, again, a much quicker adoption cycle. And again, here's some just other stuff about Kubernetes by the numbers. I'm not going to read it all to you. You can go check out the link, but you can just see the numbers are staggering. They're growing from the amount of people that are contributing to the project, companies that are adopting it, the numbers of people that are actually going and attending KubeCon and those types of conferences. It's growing at an exponential rate. So this is why you're even here watching this and we're talking about it today. And to understand exactly why that even containers became a thing too is that we had this idea of like, okay, well, we got to split the monolith up. What does this look like? Into microservices. Now, that's a horse that's been beaten to death too many times, but it does really serve a purpose because splitting services up into smaller constructs as with a container allows teams to specialize in what do they do for their services. They can do blue-green deployments. They can do rolling upgrades or actually, taking it backwards as well as downgrades. So you give a lot of flexibility in how your application is actually managed and how it integrates as well. And Kubernetes then becomes a ability to abstract the infrastructure that allows the applications in the containers to be able to take advantage of it as well. Now, many times when I give these presentations, people understand, they're like, well, I don't really care because I don't have any in-house development teams. I get all my software from an independent vendor off the shelf. And that's fine because we've all been there. We get an ISO or we get a binary or an executable. We load up a VM, we install it, and we're off and running. That's great. And at some point, a lot of those vendors became vendors that said, okay, well, we're not going to give you an ISO or an image anymore. What we're going to do is we're going to give you an OVA. And then now you take that OVA and what they did is now their tooling has become an appliance. And we became complacent with that. It's fine because that's what we are used to. Now you're going to start seeing this relative shift that's going to happen where these companies that were giving you OVAs are no longer giving you OVAs. Instead, they're going to say, here's a Kubernetes manifest, or here is a container image. Go load this up into your registry and go run it inside of your environment. This is where you're going to start seeing really that time bomb take of thinking, okay, now I've got to figure out how do I run this stuff. Because if you go to Docker Hub today, there's IBM with vSphere, DB2, Oracle Database, Splunk, MySQL Enterprise. These are all images that are out there that are commercially supported by those vendors. So the change is already happening, and it's going to be a rapid shift of how we're going to see this happen as well. So perhaps maybe you do have some in-house development teams, and this is where we start getting to the right-hand side of this, because perhaps you've got some stuff that's being built with .NET. Now, .NET is typically always reserved for Windows types of applications. However, the .NET framework is now able to run inside of a Linux environment. So you have the ability to start packaging up some of this stuff and running it inside of those types of containers. Windows containers are coming along. They're not necessarily as mature as Linux today. However, you do have that ability. Now you've got bucket number 4, which is something that perhaps you've been building stuff inside of Linux-based applications for a long time in-house, and you can really look at this as your low-hanging fruit of what you can try to put inside of a container and start utilizing right away. And how do we deploy this? How do we run it? And how do we manage it? Now, as we start progressing a little bit further, we start looking at modern development languages, Go and Node and Rust and stuff like that. And a lot of these are built with utilizing things like packages inside of the source code. And these packages aren't necessarily tied to a particular operating system or particular hardware or anything like that. Instead, these packages are all based on knowing how to call other different pieces of code. And this is really where we get to this more or less this cloud native side, where we can easily package this stuff inside of containers and we can run it easily at the same exact time as well. So you might be thinking, all right, well, I have a few containers today. I've got maybe 5, maybe 10 containers. And that's easy. And everybody knows about what Docker really does. So Docker is your ability. They really brought this to the light of actually utilizing containers. And so Docker allows us to actually package up the app and its dependencies in there. We build the application, we run the application. Simple as that. Now, as I had mentioned, it's easy to do this with like 5 or 10 containers because you can run this on a server. You can utilize Docker Compose to easily bring them up and bring them down, or maybe just some handy script. Now, this changes when you get to, say, 50 containers, 100 containers, thousands of containers. You need something that you can orchestrate this with. It's the same thing with virtualization. If I only got 5 or 10 virtual machines, do I need vCenter? Probably not. So this is where Kubernetes really starts to shine, because what I can do is I can now say I've got thousands of containers. I got to figure out, how do I orchestrate this to put on the best resources that know how to schedule it? How do I overcome failures? How do I scale it and everything like that? And with Kubernetes, I can put this all in a single deployment manifest, deploy my application into my Kubernetes cluster, and let Kubernetes take over from there. It knows what to do. It's very, very smart, and it's very good at what it does. Now, there's a lot of different value that you can get out of Kubernetes. As you can see, there's a ton of stuff here that I didn't even go into, but you can go read all that on your own. So just a quick Kubernetes architecture review. We got a control plane and we got the worker plane, or the worker node. So the control plane has a few different components. You got your API server, your controller manager, and your scheduler. And each one of these have different functions to actually make not only just front-ending requests, but also doodling control loops to make sure that you end up with a desired state. You also have an etcd database. This is actually your key value store that basically holds the state of your cluster. And the cool thing about this is that you can also scale out your control plane. So I can actually create multiple masters, connect my etcd servers together, and then I front end everything with a load balancer, and that load balancer just talks to your API server. Now, the Kubernetes worker, on the other hand, it's got, again, a few different components. Your container runtime is first and foremost. We all know about Docker, but Docker isn't used in every single application. We'll be looking at Containerd for what we're really doing a lot today, but that really becomes your ubiquitous layer across an operating system here. A kubelet is like your agent that runs on every single one of these nodes. This is actually what's responsible for creating different pods. Might be the first time you heard what a pod is. That's a lowest level construct that actually holds one or more containers. And you also have the kube proxy. The word proxy comes to mind. It's networking. Pretty simple to understand. It's going to be responsible for doing overlay networking across all your pods and that pod-to-pod communication east and west. And the kubelet's also in constant communication with the API server for heartbeating and stuff like that too. So in a non-HA setup, it's pretty easy to look. We've got a master. We've got a few worker nodes. They all communicate. And we all deploy pods wherever they go. So how do we get to this state? How do we get this to the point where we actually build our Kubernetes cluster? Well, in the beginning, there were about 82 different distributions and installers. There were choices upon choices of having, you can run it on your local machine. There's turnkey cloud solutions. There's hosted solutions, on-prem solutions, everything like that. Or you could do it yourself and you can build it yourself. And that's what we're going to be looking at today is if you want to build it yourself the open source way, there's plenty of tools out there that make it happen. And so the old way of doing this before the technology we're about to talk about is we had to figure out, okay, well, what do we do about figuring out, well, what distro do we want to use? What container runtime? How do we run this container runtime in production if we've never had any exposure to it, say even running Docker in production? Then you've got all other choices for networking and persistent storage. There was it's still a great article out there called Kubernetes the Hard Way. You can go and Google that. It's on GitHub, and it tells you exactly how you can build each one of the individual services and SSL certificates. So all the services are in constant communication. However, this is actually pretty fragile if you wanted to try to automate it yourself. Then there's Cluster API that came in. Now, Cluster API really made this super simple because it started templating this out. It predetermined a lot of the configurations of what were considered best practice or most common practices that you see. And we start interacting and combining all of the different components that have been built onto previously utilizing the container networking interface, container storage interface, and we integrate a lot of this tooling going into it as well. And so we look at some of the different components that are available. So we've got things like CSI. This is the storage provider plugin for Kubernetes. And so there's actually a vSphere driver for Kubernetes, and we have the ability to have this as an out of tree plugin, and it's consistent with best practices of Kubernetes today. So if you just want to utilize a CSI driver, there is the code to actually go and find it as well. Now you've got the Cloud Controller Manager. This is the cloud provider plugin. What this is doing, it's creating another out-of-tree driver. And I keep saying the word in-tree and out-of-tree. When I say in-tree, that was code that was actually built into Kubernetes. And over the time, Kubernetes and the kind of governing body made a decision to say, okay, well, let's take out everything that is focused for particular providers, and we'll build basically drivers or plugins. So now you see things that are considered out-of-tree drivers. And these out-of-tree drivers, again, they just plug into it for your particular components that you're needed. And so the Cloud Controller Manager is allowing us to actually talk to vSphere. That's what this is doing in this case. You also have another tool called Kubeadm. I gave a talk on Kubeadm at VMworld last year. It's a fantastic tooling for what it does. It's there for actually bootstrapping a minimum viable cluster, and it does that very, very well. However, it's not particularly tailored to an individual cloud provider or cloud solution. That's out of scope for it. So it takes all these different components and actually bundles it up and makes it super, super easy to consume. And the thing is that Kubeadm was never meant to be a one-all and be-all tool, but instead it was actually expected that there would be higher-level solutions that would take advantage of Kubeadm to actually do a little bit more of the customization and provisioning and stuff like that too. And that's what we have to figure out is how do we get to this next phase? Like, how do we extend Kubernetes? Because today, Kubernetes, it knows about certain objects. It knows what a pod is. It knows what a job is, and all these different things. But how do we make it know about things that haven't been inside of Kubernetes before? And that's where we get into what's a CRD, or a custom resource definition. This is the ability for you to extend Kubernetes to make it learn about things that it didn't know about. And when we do this is that we can apply Kubernetes, basically we can apply Kubernetes constructs or Kubernetes technologies, such as having a desired state and utilizing control loops, to anything that we want to manage. And that's really where that declarative API comes in. And so Cluster API is the tooling that actually makes this all happen. So the Cluster API, with Kubernetes, it knows about these types of objects. Now the Cluster API, we're creating this custom resource where it says, okay, well, now I want Kubernetes to know exactly how does it know what a machine is, or a machine set, a machine deployment, or even deploying a single cluster or a whole cluster. And so with this, we provide individual infrastructure as a service offerings that say, this is how you talk to my API provider, and this is what a virtual machine looks like. This is what a cluster looks like, and this is how you deploy it. And so a simple cluster API architecture looks like this, is that you have a local machine or a virtual machine like the one I'm running on, and I create what's called a bootstrap cluster that's running in Kind. Kind is then creating its own, what's called Kubernetes in Docker. So it's a single Docker container that has Kubernetes. I apply my cluster API manifest to it, and then from there, I deploy a management cluster. And once the management cluster is deployed, I can deploy workload clusters from there. So I'm actually utilizing Kubernetes to create more Kubernetes clusters. So I'll kind of show exactly what that looks like here in a little bit. So with this, as a user, I want to come in and I want to specify exactly, well, what do I want my cluster to look like? Well, I can set and say, this is what I want how many machines do I want for my control plane? How many worker nodes do I want? How big do I want these worker nodes to be? What do these templates look like? I apply that template to Cluster API, which is running in its own Kubernetes cluster. And then what this does is this talks to a myriad of other providers that are out there. Now, these other providers, again, you're you're putting the Cluster API provider for those infrastructure to service offerings into it. And so it knows exactly whether I'm talking to vSphere, I'm talking to AWS, it knows what a virtual machine or an EC2 instance looks like. So at that point, it knows exactly how to provision those virtual machines. Now, once those virtual machines are provisioned, it's already preloaded with all the necessities that are needed to actually build a Kubernetes cluster, such as the binaries in itself. And utilizing Kubeadm, it's going to go ahead and actually bootstrap it and create that cluster. So the cluster API provider for vSphere is actually available. Again, it's all open source. It's right here. There's a few different steps which you do, and I'll kind of just show exactly what this looks like here as this demo that we had kind of started over here on the back end. So right now, it's waiting a few more minutes for the workload cluster to come online, but I'll kind of give you an idea of exactly what this looks like inside the environment so far. So inside of here, as I'd mentioned, the first thing that I have to do, I'm going to go over here to my Cluster API folder. And so I've imported 2 virtual machines here. So the first is I've got my HA proxy VM. The HA proxy VM is going to be there, and that's created as a front-end load balancer for Kubernetes API server requests. Now, this is made with every type of cluster, whether it's control plane or a workload cluster or anything like that. And what this means is that it will, it's there to serve two purposes. One is to make sure that it is, it can do scale out. So if I wanted to add multiple control plane nodes later, it just gets added to the HA proxy server and I do round robin. Second is if I want to do rolling upgrades, I'm going to create a new control plane worker. I'm going to attach it to HA proxy and I'm going to demote and decommission the other control plane worker. So now I can upgrade my Kubernetes clusters in that rolling fashion. Next is I've got my Photon image. My Photon image is what is packaged with all of the Kubernetes components and open source components that are needed to actually build this cluster in itself. So how did we get to where we are with this script? Well, let's go ahead and take a look at the script. Now, this is a custom script that I built. And if you're doing this open source route, this is what you need to be actually do to actually kind of get it going. So I've basically created an input dialog that gets everything and pumps it all into a configuration YAML. So I save all these different environment variables and I save it to there. Now I'm also running this on a local machine, as you can see, right, or sorry, not a local machine, but on a almost like an appliance, if you will. So I just called it like a cluster API provider for vSphere boot image. So within there, it's running this script. So it's installing Docker, it's installing kubectl, which is how it actually talks to the different clusters. It also installs kind, which is Kubernetes in Docker, and then it installs clusterctl or clusterctl. This is the cluster API provider command line, I guess you could say, binary of what you need to actually use. So now I'm taking all of those different components that I had asked for during the prompt. I'm creating a clusterctl YAML. And then from here, I create my first bootstrap cluster. So I'm creating the kind cluster on that local image. And then I'm going to initialize it by providing it and giving it all of the vSphere cluster API components and actually installing it on there. Next, I'm actually going to go ahead. It's going to wait for the bootstrap cluster to come online. And I'm creating a new image of what I want my local control plane to look like. So going through here, I said, okay, I want a particular API version. I want one control plane, one worker node. I'm going to save this into a cluster manifest. And now I deployed my cluster manifest and it's back online. So as you can kind of see over here that the cluster manifest, it's created. It did exactly what we wanted it to do. So if I kind of roll up here just a little bit, you can see exactly what happened here. So I've got my my cluster API provider right here. So it actually installed everything that we needed. And then now the management cluster has actually been initialized. It's up and running. And now what I want to do is actually deploy the local control plane. Oops, sorry about that. And deployed a few different things to it as well. So I'm going to go ahead and just kind of go back to it real quick, just so we can, whoops, not that. So I'm going to go back to it real quick. So coming through this, the other things that I kind of note are pretty interesting as we get through here. First is that we take our kubectl secret and I export this into a kubeconfig, and this is how I actually am able to talk to my cluster. Now, a cluster is never going to be up and running automatically. It gets everything together utilizing Kubeadm, and that's where it stops. So it gets to the point where it says it's not in a completely ready state. all the stuff's in a cluster, but it says not ready. And that's because you need some sort of east-west networking, or how pods actually communicate with one another. And that's where Calico comes in. So I can deploy Calico to this particular infrastructure right here. And then from there, everything's up and running. Now, what I want to do is, after it's up and running, I do what's called a move, or what was originally called a pivot. And what this is going to do is I'm actually going to move all the configuration from the local bootstrap cluster to the local control plane cluster. Now, when I do this, I am actually taking all of the, basically what the local control plane cluster, what it knew of how to provision to vSphere, right? All of those environment variables, how it knew to actually be able to do that, and putting it into a new management cluster. And now the management cluster is going to be the one responsible for actually knowing how to talk to vSphere at this point. So we basically take its configuration and just move it from one place to another. We remove the underlying bootstrap cluster because we no longer need it after the workload, or sorry, after that's up and running. And then I want to set my context, my kube control context, actually talk to local control plane. Now, the other thing that I did is I said, okay, I wanted to also deploy a workload cluster. So when I deploy the workload cluster, I'm kind of doing the same exact thing. I'm creating another manifest, and then I'm applying that cluster YAML manifest to the control plane, the management cluster at this point. So when I do this, this is kind of where we're at. It says now I'm going to wait 12 minutes for this workload cluster to come online. It actually doesn't really take 12 minutes. It takes a lot less time than that. And I just follow the same exact process. I export my configuration, my kube config, and then I set my kube config to actually talk to it. And then I deploy Calico once again, so all the nodes are ready to go, and then they're up and running. Lastly, down here, I'm applying a default storage class to it. So if I wanted to actually create some persistent volumes, I could do that as well. Then at the end of this, I am just, again, changing some permissions. Also installing Octant. Octant is a awesome open source tool. Go Google it, go check it out. It's a way to actually kind of visualize everything that's happening inside of your Kubernetes cluster, completely open source. This was built because there was a need for, as a developer, to kind of see exactly how do all my different components inside my application actually talk and tie into one another. So definitely go and check that out. And then lastly, we can see down here, I'm just setting some more permissions. So I'm going to let that go. At this point, everything's running as it should. We can see that pretty much everything is up and running now. So we have our load balancer for the workload cluster. Here is the worker. Here's the control plane. So at this point, everything's going to be running just as we expected. So we have created a local control plane, and we've also created a workload cluster. Exactly what we wanted to do. So let me go ahead and jump back over here to the slide deck. So what we learned there is that utilizing that script, it was a bunch of stuff going through there. I know I'm screaming through this because there's so much more to go through, but utilizing that script, it made it super easy to actually go and build and deploy a lot of this stuff. However, there's a lot more stuff that we can actually go into it as well. And just know that utilizing that script, that took me the span of a few weeks to really refine and actually get it right. And the other thing is that it's a very fragile script. It breaks all the time because the way that the Kubernetes trajectory goes and the way that Cluster API and everything, the releases are happening almost every other few weeks. And for Kubernetes, it's once every quarter. So knowing how to keep up with this kind of trajectory and this kind of pace is really hard to do. So it's a very fragile script that I wrote. However, it gets the job done, especially for this type of demo. Now, there's a lot more open source components that we can start tying in here. First is Harbor. Harbor is an enterprise container registry. Now, one thing that people might think is like, well, why do I need, what's a registry? What is it? Well, it is a place where container images live. It's required. That's how your container runtime, it knows what to talk to. It knows where to pull it. It's analogous to saying if you had created an ISO image inside, or an ISO folder inside of one of my data stores, right? It's the same kind of concept. However, you need a container registry to actually know exactly how the containers actually get pulled in your environment as well. Completely open source. Go check it out. One of our premier projects. It's part of Cloud Native Computing Foundation. Definitely one of the premier projects that's out there from the CNCF as well. VMware plays a huge part into the development of this product as well. This gives you an idea of what it does look like. A lot of different features, UI all built into it. So you've got RBAC. There's also the ability to have vulnerability scanning into it as well. So utilizing Claire and Trivy and a few different third-party projects, we can actually go through, look at a container image that's sitting at rest, scan it, and see if it actually has any vulnerabilities and give you a report of what that looks like too. Now, there's always the idea of when we get into this world of like, okay, what about like backup and restore? What do we do for these types of applications where we need, and I guess we could say that we're so used to virtual machine backups. So people think like, oh, we need backup and restore for Kubernetes. Well, yes, it does make sense. You do need backup and restore some of the time. Kubernetes was really made to really fit in the envelope of, okay, well, now we have a lot of stateless services. But with anything that's stateful, we do need backups. We still do need that. And that's really where containers started to get a lot of traction, is when you could start figuring out, how do we run databases? How do we run Mongo? How do we run Redis? How do we run all these things inside of containers? And we can do that by attaching things utilizing CSI to a container. And now we can utilize Velero as one of the tools to actually back up and restore your Kubernetes cluster resources and those persistent volumes at the same exact time. So go and check that out. Another project that is heavily invested from VMware as well, all open source. So here's a simple Velero workthrough. We create the backup. It goes to an S3 bucket. That S3 bucket is then sitting with, it holds the backup, and then you say Velero restore from my bucket, and you're off and running. Simple as that. So Contour is another one. What this is actually able to do is it provides a control plane for Envoy. And this allows you to have different endpoints going into your Kubernetes application. So if you want like /app versus /blog on how you actually do that GET request, this is what's going to do that for you. And so you need an ingress controller so you're not burning up load balancer resources when you need them inside of here as well. Another open source project heavily invested by VMware. So again, this is what it looks like. So you have your load balancer resource that then talks to your Envoy proxy, contours your controller for it, and then it knows exactly how to get to your endpoint. Sonobuoy is utilized to do conformance testing. So knowing that our Kubernetes cluster is actually meeting open source specifications. And so this is something that you can run against it just to make sure that there's nothing that's been configured or doing something random inside of it. Open source, sonobuoy.io. Also heavily invested by VMware. Again, conformance testing, conformance results, pretty easy to see. And I kind of talked about Octane already. It's a GUI to kind of understand exactly what's happening inside the cluster. Go check it out. Another one coming from VMware. Another quick little demo of what that looks like. Now, I've shown you a lot of the open source projects, but the big question is that what do we do and how do we move all this stuff to production? Because there's a lot more to do than just installation, right? We showed you how to deploy clusters, and I could deploy another workload cluster, and I could continue going through that process. But how do I do logging? Like, how do I ship logs back and forth? How do I monitor this infrastructure? What do I do for lifecycle? How do I upgrade the clusters? How do I know what my security and testing looks like? How do I trust that what is being deployed is also doing against my security policies? And then regression testing. There's a lot of, as I mentioned, the trajectory of how fast this and the pace that this ecosystem moves is really hard for one person to do on their own unless they've got multiple environments that they're able to test in, as well as multiple application environments that they can do multiple application testing. So again, very, very hard to do. And also, as you see that I can deploy stuff pretty easily inside here. Now, I would just see a ton of Kubernetes clusters, but how do I get a global view? Like, how do I look into this at a better view? And so we can see right here that our script is finally run. Everything ran. Woohoo, I'm up and running. So demo gods were on my side. Now, the other part of this is also support. I mean, that's also the big one. What happens when something doesn't work? When you go the open source route, you're left basically to Slack and GitHub issues. And whenever it gets around to getting fixed is when it gets fixed. So you got to figure out, well, what other options are for me. And so that's what we'll kind of look at, the VMware Tanzu portfolio. So VMware has a few different things. And first and foremost, we look at Tanzu Kubernetes Grid. This is the blanket substrate of where you can run Kubernetes everywhere. So you can run Kubernetes as a standalone service. You can also run Tanzu Kubernetes Grid as a part of vSphere 7 with Kubernetes as part of the VMware Cloud Foundation. So it's more giving you a native-like experience. And then Tanzu Kubernetes Grid is also ran as a service as part of Tanzu Mission Control. And as a service means it's pretty much abstracted from you. You really don't see it at all. So what Tanzu Kubernetes Grid gives you is not only it's an easier installation, and we'll kind of talk about why is that here in a second with a demo, because what it does is it kind of wraps up all the open source tooling that we talked about into a nice, easily consumable CLI and package. Now, this is also where the TKG components come in, because we have a few different things. First is that we have our platform CLI. What this allows us to do is actually wrap up a few different open source packages into one. So it allows us to package up cluster cuddle as well as kind into one. So now you have a easily consumable way of actually utilizing that binary as well as standing up the infrastructure without actually having to go through everything that I had shown inside of my script. Now, the other thing is that just like the open source version, I have different OVAs that are available to me. The only difference is I mean, everything's the same in regards of the different components that are in there, but as a part of TKG, you actually get signed packages. So knowing that it actually comes from VMware and it is a signed OVA, just, I guess, gives you the warm fuzzies. Now, the other thing to kind of look at is what does the architecture of Tanzu Kubernetes Grid look like? Now, it's pretty similar to regards of what we're doing with Cluster API, that as a user, I utilize the TKG CLI and I talk to the Kubernetes Declarative API. And utilizing again, Cluster API as a part of it, I can create my TKG workload clusters. With TKG, we're also adding more components to it as well. So as I'd mentioned, you already get Cluster API. That's part of here. That's part of your lifecycle management. We talked about Harbor. Now, Harbor is not included as a part of TKG, but it will be in a future version. Today, it is a part of another service offering called Tanzu Kubernetes Grid Plus, which I'll show here in a little bit. Now, you also get Contour, which is going to be your ingress controller. Now, FluentBit is another part of this. That's your logging. So FluentBit comes as a daemon set, which means it deploys onto a Kubernetes cluster, and then we configure it to actually talk to a centralized component. So what this does is that we are now do centralized logging for all your Kubernetes clusters, and you'll get that as another signed binary as well. You also get Kubeadm as part of your cluster lifecycle, and then you have Dex. Dex is going to be your component that's utilized for doing OAuth, not OAuth, but LDAP and OIDC authentication into your cluster as well. And there's other stuff that we get. So, of course, Containerd is going to be your runtime. Calico as part of your east-west networking, crash diagnostics in case something goes bad. We can get all the logs from there. And the provided OVA as well as AMI images for running on top of AWS. Again, these are all signed binaries or signed packages that come from VMware. So you know that they've gone through our regression testing and our CI process as well. Now, one of the things that is really exciting is when we look at the Tanzu Kubernetes Grid service on vSphere 7 with Kubernetes as a part of VMware Cloud Foundation. So with what this allows us to do is be able to utilize a more native-like experience using the vSphere UI to then provision Tanzu Kubernetes Grid clusters. Now, there's a lot of other things in here in regards of vSphere pod services and networking services that we'll talk about at another time. But what vSphere 7 really gets that I really enjoy is the namespace isolation. So I can create what's called a Supervisor Cluster, which is another word for our management cluster. Now, this management cluster can create namespaces. These namespaces can provide different things. So I can do vSphere pods. I can also do other virtual machines inside of these namespaces, or I can deploy Tanzu Kubernetes Grid clusters inside of here as well. So having these Tanzu Kubernetes Grid clusters as a service inside of vSphere 7 allows us to have a conformant cluster. It also allows us that we know that we can run any type of Kubernetes application inside here, and it's going to be guaranteed to work and be guaranteed to function as well. Now, the other thing is, how do we get a visualization of all these things? Now, that's what I had mentioned before. You have this sprawl of Kubernetes clusters everywhere, and this is what it would look like to manage them all. Well, Tanzu Mission Control is here to actually alleviate that burden, because what it does is that it attaches or inherits all of these different types of Kubernetes applications, and it provides visibility into them. It also provides the ability to provision policy into individual ones as well. And this is a quick screenshot of what it looks like to run inside here too. And so this is just a quick little overview or layer cake of kind of how these all fit together. So utilizing any kind of API-driven infrastructure, today Tanzu Kubernetes Grid supports vSphere as well as AWS. We create a local control plane. That local control plane is kind of like an imaginary control plane, if you will, because inside there we create our management cluster. That management cluster utilizes Cluster API. Then to provision workload clusters, we have our workloads that are on top of there. And then we got Tanzu Mission Control, which gives us visibility across it. Now, I mentioned real quickly that Tanzu Kubernetes Grid Plus, this is an additional offering that comes from VMware. And what it does is it's the same exact technology. It's the same TKG CLI, the same technology, but what we do is we package up our customer reliability and engineering support to give you more of a hands-on and handheld experience to get through this, to kind of get your Kubernetes services up and running. And not only that, is they can help you out with architecture as well as lifecycle management processes as well. So let's jump over to a demo. So real quick, just kind of look at what the TKG CLI brings. Now, remember before I actually had to go through my script and actually input all those different variables? Well, TKG actually comes with a UI. So what I can do is I can start this up, and now I can come through here. I can deploy it on vSphere. I can enter in my credentials, and I'll just kind of do this real quickly so you can kind of get an idea of what this looks like. Oops, one more try here. I'm going to connect to it. Now, once I connect to it, what it's going to do is that it's going to start pulling everything from my vCenter environment. So I can come through here and I can choose my instance type, whether I want one workload, one control plane. I want 3 control planes, a production development environment, and these are called what's called plans. So I can go through the same exact thing, build everything out for resources, my network. I can review the configuration and I deploy it. Now, once I deploy it, it's doing exactly what we said before. It's going to utilize the client cluster to create our management cluster that's running inside of, So it's running inside of this environment here. So I'm going to go ahead and just kind of show you what's happening inside of TKG land. So we already created our management cluster here. So now that our management cluster is created, I can actually create a workload cluster pretty easily. I can say TKG, and I can just look at my help, just to give you an idea what the command lines look like here. And I can see TKG create cluster, let's see, VMware Demo, and my plan is going to be dev. So I go ahead and I create that, and then here in a few minutes, it's going to be up and running. So the cool thing is that I don't have to go and create all these different manifests if I want to. It's a simple one line to actually create a whole entire Kubernetes cluster. Now, if I wanted to, it gives me that flexibility that I could actually go through. I could create a customized plan that actually has our, whatever type of size of vCPUs and RAMs and all this other kind of stuff. Or I can actually modify this to say how many workers I want inside the command line as well. So what it's going to do is it's going to, again, start going through this process. As you can see, it's already starting to clone the load balancer. It'll start building out the control plane, the workers, and then it'll start creating the cluster. So we're running out of time. I wish I could wait and show you exactly everything that's going on here, but I want to go ahead and give you some resources to kind of get you started. So the first thing is that if you want to just do the open source route, go ahead, check it out. Here is a link to my script, and you can kind of get started utilizing that today. You can also go to Kubernetes.Academy or Cube.Academy. Within here, there are courses that have been developed by VMware engineers and customer reliability engineers, and it's all free. It's kind of just like an intro to Kubernetes. There's nothing that is all about vSphere or anything like that. It's just to kind of get you up to speed with Kubernetes concepts as well. And then lastly, go and check out the VMware Hands-On Labs. There's going to be more labs that are becoming as well. We have a Tanzu Kubernetes Grid as well as a vSphere 7 lab that are in process and actually being created right now. But if you wanted to get started even looking at Tanzu Mission Control, which, as I mentioned, has TKG under the covers as a service, it's kind of like abstracted from you. You can go ahead and you can go check that out. And if you wanted to kind of get started with vSphere 7 with Kubernetes, you can go check out the Project Pacific Lightning Lab. So you kind of just get a click through and see what that looks like as well. With that, thank you so much. I know I flew through this because there's a lot of stuff to cover, but if you have any questions, you can either ask them in the chat. You can find me online, Twitter @KendrickColeman, and I'm there to answer any of the questions. So cheers and happy Kuberneting.